Welcome to Homework Lib.
What we're going to have is the following chemical reaction. Iron 2O3 plus 3 of CO is going to produce 2 of pure iron, a solid, plus 3 of CO2. So in this case, we're given that initially we had 14.7 grams of iron oxide. We are going to have 10.2 grams of carbon monoxide, and that the final amount of iron that was produced was 9.22 grams. So the first thing that we're going to do is find which one is going to be the limiting reagent. For that, we're going to find the amount of mole for each of the compounds that we had, and we're going to calculate with how many of the other compound it can react with. So in this case, what we're going to have is that for iron oxide, we're going to begin with 14.7 grams. We know that the molar mass of iron oxide is going to be equal to 159.69 grams per mole. And additionally, we know that in the case for carbon monoxide, this is going to be the amount of mole of iron 2O3. In the case of carbon monoxide, what we're going to get is that 10.2 grams corresponds to 1 mole, 38 grams per mole. So the result for each of them is it's going to be 0.092053 mole of iron 2O3, and on the other case we're going to have 0.26842 mole of carbon monoxide. In this case, it seems that it may seem that the iron oxide is directly the limiting reagent, but we need to consider with how much of the other compound it can react. So in this case, 1 mole of iron oxide can react with 3 mole of carbon monoxide. So this means that this amount can react with up to 0.276 mole of carbon monoxide. Thus, the limiting reagent, directly without having to do the calculation, is going to be carbon monoxide. Thus, the yield is going to be given by the limiting quantity here. So the theoretical yield of iron in grams is going to be equal to the amount of mole that I have of carbon monoxide we're going to employ the stoichiometric relationship that tells us that 3 mole of this compound is going to react with 2 mole, or is going to produce 2 moles of iron. And finally, we're going to employ the atomic weight of iron, which is going to be equal to 55.85 grams of iron per mole. This is going to give us a theoretical yield of 9.994 grams of iron. Thus, the percent yield, which is the experimental over the theoretical times 100, will be, according to our question, we were able to produce 9.22 grams, so 9.22 over 9.994 times 100 gives us a 92.255% yield. So with that, it would be all. Thank you very much and have a good one.